Okay, 3M, we're on lesson number 4, and today's goal is to allow you to write mathematics in a lazy but clear way, which is always a great goal. So how we've often worded things before is determine the value of the expression for x squared minus 2x minus 8 if x equals 2, x equals -1, x equals a, or x equals a minus 2. So we've written quite a lot of things down, and we're asking you to write 4 different answers. So for the first one, when x equals 2, that's telling me find the value when I put a 2 in for x. So I'm going to put a 2 there, and I'm going to put a 2 for this x, and I'm going to put an 8. So already I'm a little bit lazy. 2 squished up to the 2 implies multiplication in the middle. I had an x squared, so I'm going to square my 2, and I'm going to do some calculations. 2 squared is 4. 2 times 2 also happens to be 4. And at the end I subtract 8. So final answer will be -8. The value of the expression when x equals -1, I put a -1 in for x. So I have, and brackets are your friends, -1 squared. Subtract 2 times -1. Subtract 8 is +1, because -1 times -1 is 1. A negative times a negative is a positive. 2 times 1 is 2. Subtract 8. Make friends with your positive and negative button on your calculator to make sure we get the right answers. Working from left to right, 1 plus 2 is 3. Subtract 8 is -5. So if I'm going quickly, don't worry about the arithmetic as much as the fact that when we're asking you to evaluate for certain values of x, we're putting that value into the expression. Strange one, when x equals a, I just put an a in for x. So I would write a squared, subtract 2a. You could put brackets there or not. Subtract 8. Done. Nothing more you can really do with that. When x equals a subtract 2, I'm putting a subtract 2 in wherever I see an x. And it's kind of ugly, but it's the same process as before. We would be asked to tidy that up. So I have a subtract 2 squared, which means I have 2 a subtract 2's. In a moment, I'm going to FOIL. And I'm sorry, I'm running out of whiteboard space. Okay. My first two, when you multiply a minus 2 by itself twice, which is what a squared is, I do FOIL. First is a times a, which is a squared. Outside, minus 2a. Inside is the minus 2 and the a right here. -2a. -2 times -2 is +4. I have the distributive law when I have -2 squished up to a subtract 2. So I have 2 multiplications to do. I end up with, sorry, I'm going to go to the next line, -2a plus 4. Negative times negative is positive. And don't forget the subtract 8 on the very end. So it's ugly, and we're practicing some algebra skills, but we know what to do. We put a minus 2 in wherever an x is. Tidying that up, I have an a squared. I have -6a's altogether. And I have no numbers when all the smoke clears. +8 and -8 cancel. So function notation is basically this. I'm sick and tired of using y equals for everything because it gets confusing. I would like to give different functions different names. So for this first example, I like the letter F for function. I'm going to call my function f instead of calling it y. This means I have a function, its name is f, and it's a function that uses the letter x. So I have, and you are going to just write this down as a reference, but I have a function named f in terms of, or the letter that I'm using for the domain is x. That's what f of x means. You say f of x or f at x. It doesn't matter. So f of 3 means substitute x equals 3 into y equals 3x squared minus 2x plus 7. We've said all that with a little f bracket 3. So f of 3 equals 3 times 3 squared. Subtract 2 times 3 plus 7. That's what the notation means. Our answer would be 3 times 3 squared, because order of operations say you do an exponent before you do multiplication, would be 9. I can do this multiplication now. It doesn't hurt anything. Minus 6 plus 7. Okay, now I'm going to do multiplication and then my adds and subtracts. 27 subtract 6 plus 7. Working from left to right, 27 subtract 6 is 21, plus 7 is 28. Don't be afraid to check my arithmetic. Function notation over here says f of negative 3. That means put a negative 3 in wherever you have an x. So I would write 3 times negative 3 squared. Subtract 2 times negative 3 plus 7. So I've been a whole lot lazier in telling you to substitute a value in and evaluating. 3 times negative 3 squared is also positive 9. Negative times negative is positive 6 plus 7. 27 add 6 add 7 is 40. F of x, or f at x, is function notation, and the f of x replaces the y, and it gives more information than just y. It tells you its name, and the x tells you the domain variable. Let's have a look at an example. The relationship between the selling price of a new brand of sunglasses and the revenue is represented by the function r of s equals negative 10s squared plus 800s plus 120. And here's its graph. It is a quadratic. It says, for A, determine the revenue when the selling price is $5. So we are asking you to find the selling price when S equals 5. So I'm going to take my equation and put a 5 in wherever I see an S. Function notation would be R of 5. Negative 10 times 5 squared plus 800 times 5 plus 120. Negative 10 times 5 squared is 25. Have your calculators ready. Plus 4,000 plus 120. Negative 250 plus 4,000 plus 120. Final answer, 3,870 is the revenue when R is 5. Let's see if that makes sense on our graph. This mark is 10. So the 5 is in the middle there. I'm going to try my best. There, that's more accurate in there. Really hard to see. 3,870 is certainly a reasonable answer from our graph. B says, explain what R of 20 equals 12,120. Function notation says we have a revenue equation and the S is in the bracket. So it's saying your revenue when your number of sunglasses is 20 is 12,120. And it's your number of sunglasses. Sorry, it's the price of your sunglasses. So when you sell them for 20 bucks, your revenue will be $12,120. C, if your revenue in terms of sunglasses is 16,120, determine the selling price. So how much do I have to sell it for to make a revenue of $16,120? At this point, we're using our graph to get that answer, and it appears they are looking at the maximum value. When my revenue is $16,120, it appears I need to sell my sunglasses for $40. Third example, I have a function. I've decided to call him g. And the domain of my function is using the letter x. So g of x is 2x squared minus 3x plus 5. The first example says find g of m. That merely says substitute x equals m in the function g. So I have 2, replacing my x with the letter m for some random reason, replacing letter x with an m, and that's what I have. If possible, I would tidy it up. This didn't change a whole lot, other than the letter is different. The next one says take your function g and replace the value of x with 3x. So wherever I had an x before, I'm going to replace it with 3x. So change color here. 3x for this x, 3x for that x, and the first x had been squared. So that's what I have, strictly speaking. I am going to tidy it up, because that's always good form. 3x squared means 3x times 3x, which is 9x squared. Subtract 9x plus 5. I'm going to do my multiplication before I add and subtract. If possible, I get 18x squared minus 9x plus 5. I can't put any of those terms together because they're unlike, so I am finished.